Lesson 83, vector addition. So I think we already talked about how to add two vectors, but there's different methods that you need to know. One's called the parallelogram method. Okay, so if we have a vector, oh wait, I want this vector to be 2, 3. So vector A is 2, 3. And then we're going to do vector B, and I want to make that 4, -1. Mm-hmm. So to use the parallelogram method, what you do is you just draw a parallelogram using like dotted lines. So for this line to have a parallel line, I mean, if I'm going to go up, this one has to be parallel. I just need the same slope. So I go up 3 and to the right 2, rise over run. So I go up 3 and over 2. So I just draw kind of dotted lines this way, and then that will go this way. And then this is my, oops, this is my vector right there.
So it's just like bisecting kind of? It's bisecting.
Yeah. And it will be 6, 2. That's the parallelogram method. And, you know, it's still just, you can check your work by just adding them together.
Why can't you just do that?
It's just if they say use the parallelogram method to show, to add these together, then you would have to show it that way.
It's more work than you need.
Yeah, pretty much.
Why would they even make it if it was easy to just add? Like, is there ever a reason that you can't have it?
Because
I'm not sure if you would, like if you were in a different coordinate system, or, you know, that you would need to know these different methods. I'm not positive about that. That's a good question. There's a head to tail method. There's no A in there. So we're going to have our same vectors where A is 2, 3, and B is 4, -1. And instead of putting B starting at the origin, we're going to start it at the end of vector A. So if we graph vector A, and then to do 4, -1, we start here instead of at the origin. So from here we would go over 4 and down 1, and that's your vector B, and there's your addition, would be at the 6, 2. So that's called the head to tail method. Okay, so now you know you have 3 methods for adding vectors, just adding the different parts, and then you could do parallelogram method and head to tail method. I always check my work that way anyway. Okay, so direction. This is a new, then it's hard to see, yeah. So the direction of a vector. So remember when we first started talking about vector, we said vectors have both magnitude and direction. This is going to be 6. Okay, so we have the magnitude we call r. And if you guys remember, to find magnitude, it's just like finding the length of the vector. So you could use Pythagorean theorem and do the square root of 6 squared plus 4 squared, and leave a space here under magnitude. So this is approximately 7 and 21/100. Then we have the direction we call theta. So theta will tell us what direction the vector is going in. So if theta is, say, 45 degrees, then we know it's going that way. If the direction is 100 degrees, then we know it's going that way. Okay. If the direction is 270, we know it's going straight down south. Okay. Yeah.
So we're always going to call that angle theta?
Yes. Yes, we call it theta. So we can find theta, we just learned in lesson 82, by doing, we could do tangent inverse. I would use that since this is an approximation number. So I would use tangent since I know these two for sure. So the tangent inverse of 4/6 equals my theta. And so that would be approximately 34 degrees. So if I know theta and I know the magnitude, if I know the magnitude and direction, I can actually draw the vector without knowing the points. So I'm going to give you some examples of problems like you're going to have here. Okay, so add the vectors vector m 0, 4 and n 5, 0, and find the magnitude and direction of the resultant vector. So when I add them together, vector m plus vector n, I get 5, 4. So the magnitude would be our square root of 5 squared plus 4 squared. I'm going to go ahead and draw it. So if I do the magnitude, square root of 5 squared plus 4 squared, it's a square root of 41. And theta, we can do tangent inverse of 4/5. Now notice, every time we do the tangent inverse, we do the y value over our x value. So theta is always tangent inverse of y over x, if you look at these as x and y. So that's going to be approximately 39 degrees. So here's our addition. Our magnitude is root 41, which is approximately 6.4 units. And the direction is approximately 39 degrees. And the way we write magnitude and direction is as r comma theta with parentheses. So we would say 6.4 comma 39 degrees. And we would put our units in here. Actually, I don't think we have to.
So what does R stand for?
R is the magnitude. So it's basically the square root of these two squared and added together. Okay, that's the end of that lesson. And